June 6, 1944, southern England. As thousands of Allied ships assembled for the largest amphibious invasion in history. Another battle was already being fought far from the beaches of Normandy. Inside vast American factories, mechanics in grease-stained overalls worked with astonishing speed. Engines weighing hundreds of kilograms were lowered into waiting vehicles, bolted into place, connected, tested, and sent toward Europe in a matter of hours. Across the continent, German intelligence officers struggled to understand how the United States was replacing damaged machines so quickly while Germany's own workshops fought endless delays. For years, German engineering had been regarded as the finest in the world. Every component was crafted with remarkable precision. Every machine carefully assembled by skilled hands. It was a philosophy built on perfection, one that had earned worldwide admiration long before the war began. The Americans believed something entirely different. Instead of building every engine as a unique masterpiece, American engineers pursued an idea that seemed almost radical: every engine block, every piston, every bolt should be interchangeable. A replacement part manufactured thousands of miles away had to fit perfectly, without filing, grinding, or painstaking adjustment. To many European engineers, it sounded impossible. War tested both philosophies. As Allied bombers pounded German industry and battles stretched from the deserts of North Africa to the forests of Western Europe, broken engines became as decisive as bullets. Every hour a truck, tank, or aircraft remained in a repair depot weakened an army at the front. Speed suddenly mattered as much as craftsmanship. When German mechanics finally examined captured American engines, they expected to find shortcuts and compromises. Instead, they discovered something that challenged everything they believed about manufacturing. Massive engine blocks seemed to drop effortlessly into place, requiring little more than ordinary tools and trained hands. It was not simply an engineering curiosity. It was a glimpse into the industrial system that was quietly reshaping the outcome of the Second World War, and the greatest surprise was only beginning. Long before American engine blocks began astonishing German mechanics, the two nations had embraced completely different ideas about how machines should be built. Germany's engineering tradition had been forged over decades of craftsmanship. From automobiles to aircraft engines, precision was treated almost as a national philosophy. Skilled machinists carefully measured every component, often fitting individual parts by hand. The results were extraordinary. German engines earned a reputation for reliability, power, and refined engineering. But that excellence came at a price. Manufacturing was slow, labor-intensive, and heavily dependent on experienced workers whose skills could not be replaced overnight. Across the Atlantic, the United States saw manufacturing through an entirely different lens. American factories were not trying to create perfect individual machines. They were trying to build thousands of machines that were all identical. Engineers believed every engine block should leave the production line with dimensions so consistent that any replacement part from any factory could fit without modification. It demanded enormous investment in machine tools, precision gauges, standardized blueprints, and relentless quality control. The goal was simple but revolutionary: make every part interchangeable. Few people outside the United States fully appreciated the significance of that idea. For the war, interchangeable parts had already transformed American industries. From household appliances to automobiles, companies like Ford had refined assembly line production to astonishing levels, proving that speed did not necessarily require sacrificing reliability. When war erupted, that civilian experience became one of America's greatest strategic weapons. Factories that once built family cars soon produced trucks, tanks, aircraft engines, and military vehicles in staggering numbers. Instead of relying on master craftsmen to individually fit components together, specialized workers repeated carefully designed tasks, while sophisticated machinery maintained Remarkable consistency. Every hour saved on the production line meant more equipment reaching soldiers overseas. Germany watched American production figures with growing disbelief. Reports arriving from intelligence officers described factories operating around the clock, producing vehicles at a pace previously thought impossible. Some German officials dismissed the numbers as Allied propaganda. Others warned that America's industrial capacity posed a greater threat than any individual weapon on the battlefield. Test came after those vehicles reached combat across the battlefields of North Africa, Italy, and eventually France. Engines failed under relentless strain. Dust clogged filters. Shell fragments pierced engine compartments. Bearings wore out after countless miles across rough terrain. Mechanical breakdowns became an unavoidable reality of modern warfare. For many armies, repairing a damaged engine meant long hours of careful disassembly, measuring worn components, machining replacements, and making delicate adjustments before everything could operate together again. American mechanics often faced a different reality. Instead of painstakingly rebuilding a damaged engine on the spot, they frequently removed the entire engine block, lifted a factory-built replacement into position, tightened the mounting bolts, connected fuel lines and electrical systems, filled it with oil, and returned the vehicle to service with remarkable speed. German repair crews noticed something unusual whenever they recovered abandoned or captured American equipment. The engines appeared almost too easy to replace. Behind every effortlessly installed engine block stood an industrial system unlike anything Germany had ever faced, and the full extent of its advantage was only beginning to emerge. The foundation of this remarkable system had been laid years before the United States entered the war. American engineers understood that winning a modern conflict would require more than powerful weapons. It would demand an industrial machine capable of replacing losses faster than the enemy could inflict them. Government agencies worked closely with manufacturers to establish common production standards, ensuring that factories separated by hundreds or even thousands of miles could produce identical engine components. Every blueprint, every measuring gauge, and every machining process was carefully standardized. If one factory was damaged or overwhelmed, another could continue production with virtually no interruption. It was an approach designed not merely for efficiency, but for survival in a global war. German industry followed a very different path. Many of its factories produced exceptional engines, but each manufacturer often relied on its own specialized tooling, machining techniques, and production methods. Even minor variations between production batches could require mechanics to make careful adjustments during repairs. Skilled labor remained essential throughout the process. And as the war dragged on, those experienced workers became increasingly scarce. Allied bombing campaigns destroyed factories, disrupted transportation networks, and forced production into underground facilities where efficiency suffered. Engineers and mechanics worked tirelessly to keep vehicles running. But every damaged engine demanded valuable time. Germany could no longer afford to lose. Meanwhile, American Liberty ships crossed the Atlantic in endless convoys, carrying not only tanks, trucks, and aircraft, but also thousands of replacement engines packed in protective crates. When these shipments reached Allied repair depots, mechanics could install factory-fresh engine blocks with remarkable speed, returning damaged vehicles to combat in record time. To German observers, it seemed almost unbelievable that such massive machinery could be replaced so effortlessly. Yet what appeared to be a simple mechanical procedure was actually the visible result of an industrial revolution. One that was steadily overwhelming the Axis through production, logistics, and engineering on a scale the world had never witnessed. Spring of 1945. The outcome of the war was no longer determined solely by the courage of soldiers on the battlefield or the brilliance of battlefield commanders. It had also been shaped by the quiet efficiency of factory workers. Engineers, machinists, and mechanics thousands of miles from the front lines. Every engine that could be replaced in hours, instead of days, meant another truck delivering supplies, another tank returning to combat, and another aircraft ready for its next mission. What German mechanics had once dismissed as ordinary, American mass production had become one of the Allies' greatest strategic advantages. The Second World War proved that victory belonged not only to the nation that designed powerful machines, but to the one that could build, repair, and replace them faster than the enemy could destroy them. The philosophy of interchangeable parts transformed military logistics forever, influencing generations of engineers long after the guns had fallen silent. Modern manufacturing, from automobiles to aircraft, still reflects many of the principles perfected during those desperate wartime years. German mechanics who first watched an American engine block seemingly drop into place without painstaking adjustments. It was more than an engineering surprise. It was a glimpse into the future of industrial warfare. The lesson of those workshops echoed far beyond the ruins of World War II. In modern war, precision alone could not guarantee victory. Sometimes, the ability to build the same machine again and again, with unwavering consistency and unmatched speed, became the most powerful weapon of all.